Hi everybody, thanks for coming. I'm Zooko, and I want people to interrupt and ask me questions, so I've decided whoever interrupts and asks me a question, I'm going to give them a Zcash shirt. Okay, so let's see, what should I tell you about Zcash? We started creating Zcash years and years ago because, like Karen, we think privacy is really important. And there's a little bit of a story about that. I always thought that privacy was politically important, but when these scientists who had come up with the Zcash protocol asked me to turn it into a live blockchain, at first I said I couldn't set aside the rest of my life in order to do that because I thought it wouldn't be commercially important. And I figured if it's not commercially important, if Bitcoin or something is always going to be the most widely used thing, then society won't get the benefits of privacy anyway, if the new thing is just a niche product. But then I changed my mind and I called them back and I said I wanted to do this after all. And the reason I changed my mind is because I decided that privacy is necessary for business. And I still think that's true. I think the rest of the cryptocurrency community is slowly coming to appreciate this fact, but there's more and more examples of how privacy is a necessary part of all mainstream business. For example, the GDPR in Europe, which forbids all companies from disclosing private information about their customers in certain ways and the wrong ways. Well, that means the GDPR in Europe forbids you from using a transparent blockchain that includes personally identifying information about your customers. And there's similar laws in the United States and elsewhere. So I really like to analogize this to HTTP versus HTTPS. HTTP is the, hold on, let's see, what kind of audience do we have here? Who knows the difference between HTTP and HTTPS? Okay, who doesn't? Great. Good for you guys for saying that. There's no reason you should know that, but I'll tell you what the difference is. HTTP was the original World Wide Web protocol in the 1990s, and HTTPS was the first upgrade of it that included built-in encryption. So when the web was new, random hackers in between you and the site you were using would be able to see your name and credit card number and home address and whatever data you were sending over the World Wide Web would be exposed to random third parties. And in 1994, Netscape invented HTTPS to encrypt all of that data so that only the authorized intended endpoint, which was the web server, would be able to see your private data. And in those first years, this was controversial. There was a faction inside the United States government headed by the National Security Agency that attempted to block the invention of HTTPS because they were afraid that encryption would undermine law enforcement and could be used for crime. And they did successfully block it for a few years, but there was a great struggle involving policy debates and hacks and entrepreneurial activism. And the policy settled on the side that encryption is actually good for society and that it's better to protect all of the users of the web from unauthorized parties seeing their data. So much so that now the United States government, like I mentioned earlier, requires this kind of protection from every business that has access to their customers' information. So this is our analogy of what's important about Zcash. Bitcoin is like HTTP and Zcash is like HTTPS, because whenever you use a purely transparent blockchain like Bitcoin, that information about you is getting leaked to everyone on the internet. And if you use Zcash for the same things, then that information is encrypted so that people who are able to look at the Zcash blockchain aren't seeing your private data. Do y'all know what a Bitcoin block explorer looks like? Who doesn't know what a Bitcoin block explorer looks like? Nobody's willing to admit that. Interesting. So we've got a lot of Bitcoin users here. I believe it. Everyone knows what a Bitcoin block explorer looks like. So a Zcash block explorer doesn't show the addresses or the amounts. So this is the difference between Bitcoin and Zcash. So if you look at the Zcash blockchain, it looks like this. And now, an interesting thing about encryption is that it doesn't make everything all black all the time. What it actually does is it gives fine-grained disclosure. It makes everything black except to the authorized parties, if that makes sense. So these things called viewing keys, which is basically a decryption key, and every transaction in Zcash has can be separately revealed without revealing the other transactions. I'm just thinking, nobody's interrupted me and won a t-shirt.
Yes. Who holds the viewing keys and when can I use them?
That's a great question. That's a perfect question. Will you give him a shirt? He looks like an L or an M. Well, the question was, who holds the viewing keys and when can they use them? Is that the question? So the answer is the recipient always gets a view key so that they can see the payment to them in the blockchain. So if you're ZSVZX, then when you look at the blockchain, you don't see any of these other 5 transactions because those are other people's data that you're not privy to. But you see this transaction, it says somebody gave you 0.14 ZAC and they included a memo that they were paying you for donuts. And when you can use it it's a decryption key, is whenever you look at the blockchain. So Zcash is the first combination of the blockchain append-only immutable data structure and the encrypted selective disclosure data structure. Okay, who knows about how blockchains are append-only, aka immutable? Raise your hand. Okay, who doesn't know what I just said by that? Some people don't know. Thanks for admitting you don't know what I just said. Good. What I mean is with all open blockchains like Bitcoin and Ethereum and Zcash, you can add new information to it, but you can't take information out of it. That's what's novel and interesting. That's what Satoshi gave us with Bitcoin, is this open append-only data structure.
Is the key unique to each transaction or unique to each user?
Great question. T-shirt. Is the key unique to each transaction or unique to each user? The answer is, well, the simple answer is it's unique to each address. So ZSVZX is an address, and like in Bitcoin, you can have any number of addresses that you want. Large. Do we have any women's t-shirts here? Oh, only one woman can ask a question and get a t-shirt. But then any other women can still ask questions, but only the first one gets a women's t-shirt. The other ones get men's t-shirts, I guess. Oh dear. Oh God. Fail.
You and NASA.
Okay, so if you're ZSW4 and you received these 3 transactions and you sent this transaction, then using your ZSW4 view key shows you all of that data. But I guess I shouldn't say you are ZSW4. ZSW4 is your address, but you can have multiple addresses, right? And the other thing is you can share view keys with other people. So if that's your address and you've received these transactions, you could send someone else like the view key, and they would be able to see your transactions in the blockchain.
Could you actually structure it such that you're sharing the view key, but only for a certain set of transactions?
Yeah.
Is it always, and what I'm saying is if you're using one specific to send or receive, that there are multiple encryption keys for it.
Yeah, that's a really good question. Yeah, you totally deserve a t-shirt for that. Large.
If that's Asian large, then you can forget it and you can give it to somebody else.
Do we bring our Asian t-shirts?
It's okay. I was happy to ask the question anymore.
There's a more fine-grained feature that I was trying to skip over, which is you can reveal a single transaction instead of revealing all the transactions associated with an address. So a good use for that would be a proof of purchase protocol, where you buy a thing and then you want to show someone proof. Like you deposited cash into an exchange and you didn't get credited, and now you want to challenge them and demand that they credit you. You can reveal a single transaction in the blockchain. You can generate a view key, which is a one transaction view key. And then either the exchange themselves or anybody else you show it to can see that one transaction in the blockchain, so you can prove that one transaction.
Okay, so then, so you have view keys that will only allow you to see certain transactions, and then there's a view key that's a universal view key.
For all the transactions associated with a given address.
Okay, so.
And that's this example here.
Okay, so in theory, if somebody had that, they'd see all your transactions, right? Okay.
All the transactions that are sent or received by a certain address.
So then you would just need to create another address to create privacy again.
Yeah, like if you shared this view key with someone, like a good example would be if you have an auditor, you're a business and you are hiring an auditor to audit your books. And one thing you can do with Zcash, which is potentially really cool that you can't do with Bitcoin or with normal legacy financial transactions, is you can give an auditor the ability to view all of your private books live in the distributed ledger, right? You can give them a view key so that they can both see all the previous transactions you've done, and any new transactions that you add, that you execute, will become visible to them since they had a view key. But then you might, their contract with you might expire, might be done, and now you don't want them seeing your future transactions after that, right? Because they no longer have that legal right. In that case, you have to start a new address. And you can give the next year's auditor the view key for your new address.
I see. Okay, and then I understand when you guys launch this, the full gamut of privacy features are not enabled by default.
Are you going for 2 t-shirts?
No, I'll take one. But I'm just curious why you did that. Right? Yeah. Because I understand that people say, people use Zcash, but really most transactions aren't private because they don't know how to enable it.
Yeah, for sure. So I skipped over that slide because it's an awkward detail. So here's another feature that I didn't mention until he brought it up, which is that we also have Bitcoin-style unencrypted transactions also possible. So this is, see the blue T's? It might be kind of hard to see in here. You see at the beginning of this one, there's a T?
Yeah.
The addresses that start with a T are transparent. addresses. And the addresses like these ones that start with a Z are shielded addresses. And so if you are looking, this is what the Zcash Block Explorer really looks like in practice. I told you, I lied and said it looks like this, that they're all encrypted all the time, or it looks like this, that if you load up the website, you won't see anything. But actually, if you go load up the Zcash Block Explorer website today, you'll see something that looks like this, where here's a transparent address that's sent 0.005Z to this other transparent address. Okay? And that's exactly the same thing as you would see if you looked at a Bitcoin Block Explorer, right? This address sent this much to that address. And you can totally go just like Google or DuckDuckGo, Zcash Block Explorer, and you'll see this kind of structure. And then here, this second one up here says here's a transparent address TF7U9, and it sent to Zcash, but it sent it to an undisclosed recipient address. So inside there is a Z address that starts with a Z, but you won't see it if you go load the Block Explorer, because that's not visible to anyone except for the owner of that particular Z address, or someone who got the view key from them.
How can I confirm that there'll only be 21 million tokens total?
That's a good question. That's totally worthy of a t-shirt, but I'm not going to answer it yet because I want to finish describing this. So, but I will. We're running low on shirts, and the men are getting all of them.
Maybe another question regarding this.
Yeah.
Let's say I've got a view key for a transaction that was, let's say, a long time ago.
Yeah.
A few months or a few years, I don't know. And now I know that somebody sent me some Zcash. How do I find the transaction on the blockchain if I want to, for example, show it in my wallet?
Okay, hold on. There are three questions now. I haven't finished answering the first one. The first one was, why do we have these unencrypted transactions and people don't use the encrypted version? So let me finish explaining about the unencrypted transactions for people who aren't already up to speed about all these things. So some people apparently here already know that we have both shielded and transparent addresses and what the difference is, but for those of you who don't, the top row is a shielded address sending some Zcash to another shielded address. And that's the one, if the sender and the receiver are both using shielded addresses, then no information is visible about that transaction in the Zcash blockchain. And then the other three combinations are, if there's a combination of some shielded and some unshielded, then it's part of that information is visible. And you can actually see this if you go look at a Block Explorer. And the first question was, why did we do this? So we could have, there was this moment like 4 or 5 years ago when we were planning this project, when we had to decide if we were going to implement just the top row, just implement shielded addresses, and then deploy it to the world, or if we're all to support the unshielded addresses. And we decided to support the unshielded addresses because it would make it easy for implementers of tools and services like exchanges and wallets and products and hardware wallets and so on. The unshielded addresses are very Bitcoin-like, so as an implementer you can just cut and paste your Bitcoin code and implement the unshielded side, whereas the shielded addresses have some really heavy-duty novel cryptography, and it requires a whole lot of computation power. So if you want to generate one of the shielded transactions, when we first did this 3 years ago, it would take like 2 or 3 minutes of maxing out your CPU on your laptop like this to generate one of those transactions, because it required such computationally difficult encryption to generate them. So for those reasons, we decided we needed to provide the unshielded ones as sort of a onboarding option to make it easy for people to get started. And that, I think that's worked, because we have Zcash got added to almost all of the code bases and services and wallets and everything right away. But it only got added in the unshielded mode, if you see what I mean, because that was the easy thing. And so now we're at the second stage of that, where we want to push people to upgrade to the shielded mode more.
I have a
Wait, somebody has a question back there.
Okay, so what's the trade-off and how much more transaction fee I pay to the miner? As in, what's the throughput of the whole network compared to, say, Bitcoin? Probably not. And the throughput, and do the miners expect more transaction fee for the shielded transactions?
Okay, good questions. But now wait a minute. I've got two questions I've queued up. First one was, why do we do unshielded at all? And how many, I think the question was like, how many people use unshielded or something like that. And the answer is that most wallets only support unshielded, so most people can only send or receive unshielded by default because the wallet that they have doesn't do shielded. So that's a thing that is going to be changing this year. 2019 is the year of wallets upgrading their Zcash support to shielded Zcash support. The next question I didn't answer yet. Oh, yeah, but wasn't there another one between those two that I also didn't answer yet?
Verifying the 21 million total.
Oh, yeah, verifying the 21 million. Okay, that was the next one in order. How do you verify the 21 million? Oh, so that's a really good question. Because, like, how do you verify the 21 million in Bitcoin? Which is, I guess, you replay the entire blockchain and recalculate for yourself whether... He already got a t-shirt for this question. Oh, yeah, that guy. All right. Of course not. And in Zcash, if there's one of these, see that transaction at the top, how do you know it's not transferring 22 million Zcash to someone? Since you can't inspect it in the blockchain. And the answer to that is that the core technological innovation in Zcash is using zero-knowledge proofs. A zero-knowledge proof is a way that you can prove cryptographically. You come up with this proof, this cryptographic proof. It's kind of like a secure hash function, but it's a secure hash function that proves you knew the secret key for spending some Zcash, and you haven't previously used that Zcash and double spent it to anyone else. And everyone knows you couldn't come up with the secret key to spend 22 million Zcash because there weren't 22 million Zcash before this transaction. Does that make sense? That's the basic answer, is zero-knowledge proofs, which is a novel field of cryptography that no one has ever used. It's an important part of science. It's been studied by scientists for decades, and the people who discovered it got the computer scientists' equivalent of the Nobel Prize. It's called the Turing Award, and it's like the most prestigious prize for a computer scientist. They received that award for coming up with the whole idea of zero-knowledge proofs, but Zcash is the first application of zero-knowledge proofs that put it into use and demonstrated to the world that it could work in practice and it could be valued. Anyway, a lot of our founders at Zcash are some scientists who were pioneers in that field of zero-knowledge proofs. And then the next question was, if you get paid, how do you find out you've gotten paid? So your wallet downloads and scans the entire blockchain and tries to decrypt each transaction. It says, is this one for me? I'll use my decryption key on it and see if I can get if I can see the contents of it. Oh, I can't, I guess that one wasn't for me. Then it does it again and again. So it has to try to decrypt every transaction in the blockchain, and all the ones that it decrypts, it sums up, and now you have those coins for your use. And now I'm almost caught up, but that guy's question was, how many transactions can you do?
And the transaction fee.
And is the fees different for shielded and unshielded? Is that all? Is that part of the question? Well, it's a kind of a subtle answer because the blockchain's not full. So since the blockchain's not full, the fees are negligible, right? So currently, every transaction, whether shielded or unshielded, pays 0.0001 Zcash, which is like 5 cents or something, US. And it doesn't matter whether they're shielded or unshielded. If we had more and more usage and the blockchain got full, then there would be an interesting problem about that. And if we get to there, we're going to make sure that I have an idea in mind for how to make sure that shielded transactions don't have higher fees, because we don't want to discourage people from using shielded transactions. Does that answer your question?
But don't you think if you're offering me an additional feature and then I should be willing to pay more for that? So it's totally fine for people to ask more for a shielded transaction.
In general, yes, but privacy is a collective good, not an individual good.
Okay.
So if, you know what I mean by that?
I know what that means, but it's like using the VPN. I pay for the VPN even though the government might scan my web browser history. So that VPN is giving me an additional privacy.
Yeah.
Yeah. So that is what I equate to. So for me, it's a private good, and for you, it's a collective good. So that
A positive externality. Yeah.
Yeah.
Yeah, it is beneficial to you. It doesn't cost much more to the miner.
Okay.
So there's a minimal added cost to the world,
Because they are
but there's a large added value to the world to have shielded be the default so that everyone has more privacy. Oh my gosh, there's like 10 people who have questions. This is great. Wait, hold on just a second. I finally caught up on the question answering. Let me see if there are any other things I want to tell you myself. Oh yeah, I can explain why regulators should require Zcash to be approved in all their countries. But let's answer questions instead. Who's next? Do you know? Who was him?
Not related to regulators. Is there a way I can do a viewing key that the person who receives the viewing key cannot pass it onwards to a fourth party?
So the question is there a way you can have a viewing key? So I can give you a viewing key, but you cannot give the viewing key to another party. No, there's no way to do that. Let me explain it more. There's no way in computers, there's no way in math to do that. The only way it would be possible is with DRM. You know, if your operating system and your hardware will, I don't tell you the key, I give you something which you can put into your hardware, and your hardware will use that thing, your DRM-enabled operating system will use that thing to decrypt and show you stuff, but it will refuse to share that with a different device.
What about like a one-time use key?
So at this layer, assuming no DRM, assuming general purpose computers, all right? So assuming that DRM doesn't exist, it's just flatly impossible to tell someone something while preventing them from telling anyone else that. Right?
Okay, so for example, so it's just decrypt something on the blockchain, and then the blockchain executes codes that make that key no longer usable. I mean, it's just not a feature in Zcash, is what you're saying.
No, I'm saying it's impossible without DRM.
Okay.
If you live in a world with only general purpose computing, it's impossible to it's impossible to take back, there's two things that are impossible in general purpose computing that people always want to do, but you can't with general purpose computing. One is tell someone something and then take it back. Like, I'm going to tell you my locker code number or whatever, and then later say, that thing I told you, I'm untelling you. You can no longer know that thing, right? There's no way to do that. Well, you can do it with DRM, right? Like, Amazon sells you a book, and then they can change their mind and say, actually, I'm not going to sell you that book. I'm taking the book back out of your phone, and you can't stop them. But that's only because the phone is willing to do what they ask, despite your protestations. It's only because the phone. But if you have your own general purpose computer, then there's no way for them to untell you something. So the first thing you can't do is tell someone information, then untell them. The other thing you can't do with general purpose computers is tell someone something and make it impossible for them to tell it to someone else.
I think there was some ideas floating around more of a crypto economy when if they reduce the fourth party, then they have economic loss.
Yeah. Okay.
Yeah,
I'll tell you.
Which they have to stay.
I'll tell you a secret, but if you tell any of your friends, then I will punish you. Tell your friends what you did.
One example of that is if you mix the viewing key with the other person's private key, that way if they give someone else the key, it's also giving access to their wallet. No?
Something like that could happen. It boils down to, yeah. Yeah, well, hold on. That was only the first of the like 10 different questions that popped up at that moment. Does anybody, are the other 9 still, or that? Thanks.
Just suppose I started with a transparent service and later on I moved to the encrypted service. So how about the past transaction? Will I will get a new address?
Yeah. Yeah. So if you received 0.005 Zcash and then later you got a new wallet or you got an upgrade to your wallet, so now you can have shielded. You make a new address and that one is a Z address. And you send your 0.005 Zcash from your T address to your Z address. Question from a woman.
Second question on privacy. So there are 2 other projects that's doing privacy-related issues. The first one is Monero, where they use multi-signatures. The other one is Zcoin, which is something similar, but they actually burn the token after each transaction, so it's not possible to do that. So can you objectively compare against? What's your comments from an objective point of view? Which privacy method is actually better?
Yeah, I know about those 2. And there are some others, some other technologies that are coming along too.
Can I pin to Zcash that question as well?
What's that?
Zcash also?
Zcash is another
As long
one.
as you're commenting on those, yes, please.
Yes, but how much time do we have? When do we have to stop? That's my only question. Because this is great. People are asking lots of questions. Actually, seriously, when were we supposed to stop? I forgot to ask that part.
Officially 8:30, but I think we may be able to stay a bit longer.
Okay, well that's 45 minutes from now.
All right.
It's only 7:45 already.
We can stay until someone kicks us out.
Oh, okay. All right.
Permissionless. Yes.
So, objectively, Zcash is way better than those 2. So, I don't have a chalkboard in here so I can start showing you diagrams of why.
Yeah.
Guys can lift it up.
So, I don't think I can explain why right now.
You need a
I think I'm not going to start drawing the diagrams about how Zcash is better than Monero. Well, I mean, because there's also 8 questions. How about if we run out of questions, I'll come back and draw a diagram of why Zcash is better than Monero. Good deal? Good. Do you want a t-shirt? All right, of course. Of course.
So,
Thanks.
just to confirm, the recipient can generate the view keys. Is that correct?
The receiver?
Recipient recipient
The
can
recipient-
generate the view keys?
Yeah, it's like this. The sender sees,
What about the sender?
the sender sees CSW is the sender here. And they see all 4 of these fields of this row. And they're the recipient here, and so they only see these 3 fields of that row. Because, does that make sense? The recipient sees the recipient, the amount, and the memo. And the sender sees the sender, the recipient, the amount, and the memo.
So sender sees everything, recipient is not able to see the sender.
Right.
And what about the view keys? So recipient can generate the view keys? Or is it only the sender can generate the view keys?
They both can. The recipient can generate the view keys, yes.
And the view keys only allows viewing of what the recipient is able to see.
Yes, I think so. I'm pretty sure that's correct.
And one last thing is Zcash UTXO.
Basically, yeah. Yeah. How many people don't know what UTXO means? It's similar to what she asked about Zcoin, is that every amount of money is a use once object. And the other alternative, so UTXO is short for unspent transaction output, but what it means is the internal data structure is that it keeps track of a set of coins, and each coin can be used exactly once. The alternative is what they do in Ethereum, where it has a set of balances, and balances can be increased or decreased. Does that answer all your questions?
Yes.
Okay, I think I was going to say something else, but I forget what it was. Okay, who else? Wait, you already got one, and I thought there was some other people who were waiting. You already got 2. One, okay. You can have a second one in a minute.
So privacy solutions like Aztec and Enigma, etc., are they also along similar lines, or is that something totally different?
Aztec is a privacy feature layered on top of Ethereum. I think it encrypts the amounts, but not the sender and receiver. I don't remember. I haven't studied it very much. Sorry.
I think within the crypto space, it's kind of taken for granted that privacy is a good thing, but we've seen regular users always trade off privacy for convenience over and over again. So I kind of have 2 questions based on that. How do we get normal people to care more about privacy? And then also, how do you fight the attack surface later on if cryptocurrencies get big enough, where people say the only people who want to use privacy coins are criminals or people who are using it for shady practices? How do you make people care or realize that privacy is a very important thing?
What was the first question?
How do you get normal people to just care about privacy in the first place?
Can I
Good
answer
question.
that? As a
Yeah, let's have Karen
practical
answer.
Normal people don't care
Care
about
about-
privacy because privacy is a default and need space. To transit to the digital economy where privacy is off all the time, you really have to make that mental switch in your thinking.
Right.
And most people, if you see from Facebook usage and Twitter, they don't
Exactly.
care.
They trade it off every time. Right?
So you actually
No, I don't think that's
have to-
true.
You have to nudge people to actually by default be private.
I don't think it's true that people consistently trade off privacy for convenience. I think people are very thoughtful about which of their friends are going to see what. That means they care about privacy. And the other question was, how do you, you got 2 questions. Do people care about it? Well, one thing I like to harken back to is the history with HTTP versus HTTPS. Because we've gotten to the stage, and I was sort of part of that industry all along from before HTTPS until after like 20 years, until HTTPS became the default. So that we've gotten to the stage to where deploying something with only HTTP would be considered irresponsible or questionable. Like, you'd have to explain, why are you not securing this part nowadays? But for the first like 15 years, it was the other way around. You had to explain why you were going to the extra mile to secure something. There's sometimes a trap where you care about privacy, and everyone cares about privacy, but you you effectively, like, what are you gonna do?
Yeah.
Not go to Facebook?
Right, exactly.
And not go to get invited to any parties and not see any more pictures of your grandchildren? So I think some of that story about consumers not really caring has actually been self-serving propaganda put out by those companies that were monetizing that. But anyway, what was my point? My point is, I think that there is also pressure from consumers who don't understand anything about encryption, but know that they want to feel safe, and know that if some services give them the feeling that they're like trustworthy and safe, and other services give them the feeling that it's sketchy and they're in danger, then they know which way to go. Anyway, so we do have at least one success story where everything in the world went from unsafe to encrypted using end-to-end encryption in spite of resistance from the biggest government, or like the government of, so the United States government, which is where that technology was being developed, and in spite of confusion and potentially, what's that word, lack of caring, forget the word for not caring. Oh, I'm tired. Yeah, apathy, that word. Anyway, so I think it's possible. The other question was, what about pushback? Yeah, that's an interesting one, which does lead to some of my other slides. Does anybody else want to say anything before I talk about regulatory policy? So we've been going around for years now explaining about how this stuff works, and then arguing to regulators that they ought to encourage and support encrypted blockchains. And here's our argument. You are the national regulator of Singapore. And if Singaporean citizens are using Bitcoin, then you, the Singaporean government, can see their transactions, which is fine. But also, like, the government of Russia and China and North Korea and USA and France can also see their transactions, which might not be fine for you. And finally, non-governments like hackers, advertisers, jealous ex-boyfriends and ex-girlfriends, and anyone else can also see their transactions, which is really probably against your national policies right there. Now, what if your Singaporean citizens start logging into Liquid? No. What's a foreign exchange that's not going to come to Singapore, Josh? Gemini. What if your Singaporean citizens start logging into Gemini in New York using encrypted, shielded addresses? Well, now the government of Singapore can no longer see those transactions. You no longer know what your citizens are doing with the blockchain. But the government of New York can see what the Singaporean citizens are doing. But at least all of the jealous ex-girlfriends of the world can. So what you really want, government of Singapore, is you want Binance and Liquid to set up shop in Singapore and do shielded Zcash in Singapore, because then the government of Singapore will be able to see the Singaporean transactions. The government of China and New York and Russia won't. And everyone else in the world won't. So the row you want is the bottom row. You want an exchange to set up shop in your country and to offer encrypted Zcash. That's better for your national policies than Bitcoin. That's my argument. So we've been going around making this argument, and somewhat to my surprise, the government of New York was persuaded and went ahead and approved. This is the seal of the financial regulator of New York. And they went ahead and approved Gemini and Coinbase and Circle and BitGo and all the other New York companies to to support Zcash. That's the end of that story, I guess. Any questions?
That seems to suggest that you can have multiple addresses that can view a transaction, which is the regulator and the user to send.
Yeah, so the question is, that seems to suggest you can have multiple addresses which can view a transaction, but don't think of it as addresses, think of it as, well, for starters, if you're an exchange and you are privy to information, like you get to see scans of your customers' ID cards when they sign up, and you get to know the IP addresses of all your customers when they connect to your server, and you get to see all their transactions and buys and sells and all that stuff. So among the information you get to see if you're an exchange is all of the transactions that you sent and received on the blockchain. With me so far?
So the keys are on the exchange and not
If the exchange is a counterparty, like if you deposit money into an exchange, then the exchange is the recipient. So if ZSW4 is Binance, then every time a customer deposits money into Binance, the SW4 is able to view that transaction on the blockchain so that they know they got paid, so they can credit the customer's account, right? Anyway, my point was all information, even non-blockchain information, is something that you could disclose to law enforcement under appropriate procedures, right?
So what you're basically saying is we shouldn't be using exchanges. If we're really truly-
The question is that your second question? You only get two,
No,
just kidding.
that's my comment.
The comment is, so this means you shouldn't use exchanges. No, that's not what I think at all. Well, I mean, I don't know if you, what I think is that you shouldn't think of privacy as a binary thing that you have it or you don't have it, or even as a scalar thing, like you want to have more of it instead of having less of it. What you should think is, to whom is your information exposed? Is it okay if your wife sees your information? I don't know, but is it okay if Gemini sees your information? I don't know, but that's the question. It's for you to answer. Is it okay if your government sees your information? That's up to you to answer. Is it okay if other governments also see your information? That's also up to you, but I think a lot more people are going to shift at that point, right? You know what I'm saying? Like I don't like to go around arguing that people should distrust their wives or exchanges or governments, but I think they should be aware that there's...
If you're really truly seeking the ultimate level of privacy, then you shouldn't be using exchanges either. Zcash.
Yeah, if you don't want an exchange to know your finances, then you definitely shouldn't use that exchange. I totally understand it. Oh boy, next. Wait, actually, I think I've just been picking whoever's closest to me because I can see them. So if you want to ask questions, move to the front. All right, just kidding. I'm going to try to... You haven't asked any questions yet, have you?
Okay, so my question is, like, what is, like, comparing two approaches, like, one is the BIP39 approach of, you know, getting some privacy, the mnemonic seed phrase one, another is the zero knowledge proofs. So, like, how would you compare these two? Like, in a way, the BIP39 is easier, like, it doesn't require much higher computational. That would be one benefit of it.
Wait a minute. BIP39 just means you make a new address for every... It's called self-addresses, right? Is that what BIP39 is?
Yeah.
It just means you can make more and more. It effectively is pretty much the same thing as just making a new Bitcoin address for every time you want to receive another Bitcoin payment.
Yeah, so that is one way of achieving privacy, right? I mean,
No.
So how?
Well, like...
If I were to have...
like if... So, if you're using Bitcoin or Ethereum, well, forget about Ethereum because it's balances instead of UTXOs. If you're using Bitcoin, it looks like this in a block explorer. And one of these half-assed methods of getting privacy that people came up with is make a new Bitcoin address for every time you want to get paid. And I call that half-assed because as soon as you spend that Bitcoin, you're going to end up combining it with the other payments you've gotten, right? This is something that's really non-obvious. It's kind of hard to explain. Like when Bitcoin was new, everyone thought, not everyone, but a lot of people thought, since it doesn't have your name or address, your home, like your physical address, in there, then it's private. Like people always used to say, Bitcoin is anonymous, Bitcoin is private. And it reminds me of actually when the internet was new, people literally thought because IPv4 dotted quad addresses don't have your name in them, that the internet was private. Which is basically the exact same sort of mistake. But anyway, the thing that's not obvious is if you take a table like this of a whole bunch of transactions, even though the sender and receiver are just random strings, and then do like graph analysis or machine learning or different kinds of analysis on it, you can deduce a whole lot of information about the actual behavior of the actual participants. So again, like maybe after I show how Monero sucks, then I can show how BIP39 sucks. But it's a little bit complicated. Next.
Yeah, given the I guess privacy features, do you have a sense of what qualitatively the users or type of transactions that you have on Zcash versus like Bitcoin, for instance?
That's a good question. The users and the type of transactions. I don't know what those. I don't know much about that. We have a lot of transactions on the Zcash blockchain, and I don't know what they are.
I mean, wouldn't it be interesting to find out if people are using it specifically for the privacy?
Yeah.
Purpose of edge?
Yeah, I do know some
But I
things.
guess, given that part of your selling point is that you're shielded. Right?
Yeah. I do know some things that people like. I hear people talking about it. Well, for example, a whole lot of nonprofits accept donations in Zcash, and either that's because they value privacy as a social good themselves, or it's because their donors like to have privacy when they donate. They feel safer donating. But that's an example of users that I know who they are because they do it, like they talk about it publicly. By the way, I said Monero sucks, but that was kind of a lighthearted way to say it. I really like, there's a lot of things I really like about Monero, about their, both their architecture, the technical architecture, and their community and the development team and stuff like that.
So I've spoken to some guys in the Zcash community.
Oh yeah, sorry, I forgot to include that
Which
one.
at least a fork of Zcash, right?
Yeah.
Yeah. So do you or the Zcash Foundation, do you do any like outside consulting for third-party organizations?
I don't. I mean, I serve as an advisor to a few different organizations. Most of them were because I agreed to do that years ago before I realized how overwhelming Zcash was going to be. But I feel I'm too loyal to back out now, so I continue to give them advice. And then a couple of them are kind of like spin-offs or affiliated projects to Zcash. Like the new one that we're just about to announce, which is a layer 2, it's like Lightning, but with privacy built in. It's called Bolt.
Okay, well, the thrust of it was that you guys were doing a lot of work for banks, but.
Oh no, we did this one project, this partnership with JP Morgan about 2 years ago. Yeah, but we're not doing more right now.
Thank you.
Have you guys considered working with central banks? Because that's what central banks need privacy in order to issue digital fiat effectively. And if you have privacy, it allows central banks to actually coordinate the economy efficiently.
Yeah. I agree with you. I'm kind of interested in it. I haven't really. I've talked to some central banks to sort of like give them a lecture like this one, but we haven't entered into any publicly known anything.
So my question is on like what will happen when the blockchain becomes too big, and then do you have any solutions?
Well, what happens when the blockchain becomes too big? Yeah, I'm interested in changing the Zcash protocol to be more scalable, both in how many simultaneous current users and also in how it deals with a long history. But that's way too complicated to get into now.
Okay.
Let's see. Have you asked any questions? All right.
You asked about the computation power used to create a sheet transaction. So it was around 3 minutes
Yeah.
transaction. Could you improve this time, and where's the limit?
Oh, good questions. I love those questions. So that was the first version 3 years ago. It took several minutes, like I forget, like 2.5 or something minutes on a modern high-powered computer to generate a single shielded transaction. And then we spent more than a year inventing new improved cryptography that I'll explain right after the other 3 big complicated things I'm going to explain tonight. And that dropped the runtime by about a factor of 20x, I think, to just a few seconds. So version 2 of Zcash, which is now live, only takes a few seconds on a laptop to generate a transaction. And the other question was, what's the limit of that? My intuition is, I want to improve the cryptography to get away from the one-time parameter generation problem. There's this thing called toxic waste. You know about that? Well, I want to improve the technology in different ways to make it safer, even more than reducing the performance penalty even more. Because getting it down to a few seconds is basically probably good enough for most users. So I think my answer is the practical limit is right around here. We're at we're at 2 to 4 seconds on a laptop. I think we might be able to get like a 2x improvement from there, but instead of getting a 2x performance improvement, we're probably going to improve the safety. Does that make sense?
Question. So what do you think about stocks compared to stocks?
Yeah, Starks is one of those newfangled zero knowledge proof improvements that improves the safety in this way by not having a parameter setup vulnerability. And I'm excited about the possibility of it. That's my answer. Well, right now it's Starks are too inefficient. So I said I'd be willing to keep the 2 to 4 second run times, but actually I have my other slides here. Starks take, I think, maybe 50,000 bytes or 100,000 bytes per proof. So that would be too big to put into every transaction. So that's basically a showstopper for now with Starks.
Thoughts on privacy features in Google Window protocol?
It's another one that I don't like. It's,
Go on, yeah.
Well, it's another one that I like, but it's just not good enough, and it's not as good as our approach. And like with Monero, I really like the developers of Memorable and the community. And I'm glad that people are trying different approaches in case some of them, we'll learn more from trying multiple different things because this is a novel area of research. The Mimblewimble protocol is interactive, so you can't receive money unless you're online to perform some interactive protocol in order to receive. And it doesn't really protect you from the person who's paying you, for starters. And that's a really important kind of privacy. Like being able to accept money from someone without making yourself vulnerable to that person is a really important use case. And it doesn't really protect you from the minors and the full nodes that are online at the time you're getting paid, which is another super important.
Vulnerability in the way of like being identified? What's your idea?
Yeah, that's what I mean. Like it doesn't, currently, I mean, to be fair, Zcash also has a whole lot of limitations and problems currently. But, and we're both Mimblewimble, Monero, and Zcash, and others will continue improving in the future. But currently, Mimblewimble doesn't protect you from anything except from someone who comes along later and looks at the blockchain, right? So it omits information from getting appended to the blockchain that would later be able to identify or trace your activities. But it doesn't protect that information from the live network at the time that you made the transaction. Anyway, so that's some of my problems with it. But like I say, it's improving. Just want to make sure we're not missing anyone else who wants to ask any questions. What do you want to ask?
It's actually one question
Yeah?
here. Is anybody working on hardware acceleration?
That's a neat question. Not that I'm aware. I do think the current version of Zcash is efficient enough. I like the idea of hardware acceleration because then we could get the stronger cryptography and also good performance. Yeah, that'd be cool if someone wants to do that. Let me know. Like Starks, there's several candidates. Starks, Bulletproofs. The new one is called Sonic. I think those are the three candidates, unless I'm forgetting something.
Very simple questions. Did you guys issue under any sort of security exemption in the States?
We didn't do an ICO. Instead, we did this Founders Reward, where the first 4 years, consensus rules send some coins to the founders. Like 20% go to the founders and 80% go to the miners for the first 4 years. And therefore, we didn't take any money from the public.
Are there areas that you would like to get developer attention on in whatever you're developing right now?
Are there areas we'd like to get developer attention on? Sure, lots. There's a huge list of different things that the Zcash Foundation is asking for or giving out grants for. You can find it on their site. We're always interested in wallet experiments, like user interface experiments. Like, I don't know if you've noticed, but all of cryptocurrencies are horrible and completely unusable by normal people. Like, it's baffling and inconvenient, and it's also terrifying. It's baffling and terrifying. Like, only people who are into crazy, scary stuff find this to be fun. So improving UX, which is, and it's not just a matter of work, it's also a matter of, I think, innovation. Like, there's a bunch of unsolved problems of how you can make a cryptocurrency not be baffling and terrifying. There's integration with all kinds of other things, like cross-chain, like sidechain kind of deals. Hey Josh, can you think of a whole bunch of other things we want developers to do? I can. There's integrating Zcash into like a messaging system because you can use the blockchain for transmitting secret messages. This actually happens. Like, see the I love you message? This actually happens in practice. People send each other love notes through the blockchain. Since it's encrypted, it's like carving your initials on a tree, so it's permanent, but only you and your lover can see your initials on the tree because it's encrypted. Okay, I am so jet lagged. And it's 8:15. Shall we stop? Is it 8:15? All right. Okay. So the thing about, all right, I won't stop. How about I give you all permission to go unless you want to see the problem with Monero? Do I get access to my other slides?
Which slides?
I think I'll just draw it on the whiteboard. That'll work better. Thanks. How about if I just put this down and start shouting, and you can move to the front if you actually want to hear what I'm saying, okay? Where's the eraser? Here you go. Okay, so the problem with Monero is that it hides the amount of money that's being sent. There's three different things that you need to protect, and Monero protects them with three different technologies: the sender, the recipient, and the amount. Monero hides the amount with what I would call a strong technology. The amount in Monero is encrypted, by which I mean there's just no way an unauthorized party is going to be able to figure out the amount because encryption is strong. Okay? That's fine. The recipient is hidden using stealth addresses, and one thing you got to know about stealth addresses is that it doesn't hide you from your sender. So stealth addresses are a way, it basically means the sender knows who they're sending to, of course, but stealth addresses mean that everyone else who's watching doesn't know the real address of the recipient. And then, but the worst part is how Monero protects this, which tries to conceal who the sender is. In Monero, it's what I call a decoy-based privacy technique, which is there's the real sender, and then there's a number of decoys, like 5 or 10 decoys. And you can't tell which of these 6 or 11 addresses is the real sender on the decoys. Does that make sense? So, yeah, I guess I'll just hold this like this. So, so if this is the recipient, and this is the real sender, what you see in the Monero blockchain is several randomly selected decoy senders. I'm going to use 3 since I ran out of space, but it doesn't matter if it's 3 or 30. Okay, in Monero in practice it used to be like none, and then it was 2, and then it was 2 to 4, and now it's 10, but all of that doesn't matter. It doesn't matter if it's 10 or 30 or 100. The reason why it doesn't work, and I'm going to explain, it doesn't matter how many of these there are, as long as it's a small number of them compared to the total number of all senders in the whole system that are possible. Does that make sense? Okay, so what you see is this mix-in system says one of these 4 sent money to the recipient, and what we're protecting is you can't figure out which of the 4, okay? But there are all these other people out here, like the other 100,000 possible users, and you know it wasn't them, right? It was one of these 4, but it was definitely not any of these million. Okay? With me so far? All right. The problem with this is this is actually a whole lot of information. And in this kind of cryptography, it turns out that information like this can be bootstrapped successfully to expose a whole lot more than you thought, than you would have intuitively guessed. And this happens over and over, and this is one of those examples where it does happen in this case. And here's an example. Suppose you are a vendor of Bibles, right? So you use Monero to protect yourself from the anti-Bible police catching you. And so you accept Monero payments, and then you deliver people Bibles. And then eventually you've got to deposit your Monero into an exchange to get one or whatever to pay your bills. So here's an exchange or another third party. You go over to the recipients. Maybe you don't deposit to exchange. Maybe you pay your landlord in Monero. It doesn't matter. The point is you eventually have to move it on to some third party. So if I'm the anti-Bible police in this country, I'm going to catch you instantly. It'll take me like a week to figure out who you are and put you in jail for selling Bibles. What I'm going to do is I'm going to sign up and pretend to be one of your customers. Right? I'm going to go to the Bible's dark web and order a Bible and send you some Monero. And so I'm this guy, the anti-Bible police. And there's going to be these 3 other. Oh, this isn't going to matter. Sorry, this part is protecting me. It's not protecting you. So this part doesn't matter. But then when you deposit your money into an exchange, you're going to use 3 different decoys, or 30. I just ran out of room here. Okay. Now the purpose of these decoys is to prevent someone from figuring out that it was really you who deposited into this one account, because the exchange knows your real name, so the police are going to find you if they find out that this account at the exchange is the Bible vendor. Make sense? So what I'm going to do is I'm going to send you a payment for a Bible, and remember, stealth addresses don't conceal the recipient's identity from the payer. Because you kind of can't, because the payer needs to know who they're trying to pay, right? So I'm going to send you a payment, and then I have the ability to watch the blockchain and see when that particular stealth address that I used to pay you, when it is part of another transaction. And when that happens, it's going to be part of a multi-sender transaction because of this is called ring SIGs. Is the technology that allows you to bundle together the decoys with the real sender. Now, I don't know if this means that the account that you deposited into is really the Bible vendor, or if it was really one of these other people. It's really their account. And this account this stealth address just got picked randomly as a decoy, right? I don't know if it was one of the 30 decoys or if it was the real depositor. So I have a little bit, you, as the Bible seller, have a little bit of plausible deniability, like, oh, it wasn't me, must have been one of those other 30 guys or whatever, okay? So, as the anti-Bible police, what I'm going to do is wait a week, and I'm going to buy another Bible from you. Right? So I'm going to send you another payment, and the next time you deposit into the exchange, you're going to pick 30 other random decoys. You pick random decoys every time. So what I'm going to see is 31 random identities deposited my first payment into the exchange, and then one guy plus 30 other random identities. I'm not explaining this very well, I'm sorry, I'm so jet lagged. But like, there's gonna be 31 candidate members of the first transaction and 31 candidate members of the next deposit that you deposited a week later. But only one of them is going to be the same person that I paid both times, right? Because the other 30 can be randomly picked out of a million, out of all the possible guys, right? So, game over. So the Bible police know exactly which exchange account they bought 2 Bibles from. The end. And that's a deep, deep problem with any decoy-based system. Like I say, Monero is really clever, and they've been working really hard on it for years and years and years, longer than Zcash existed. And they've been improving it in lots of ways, like improving the number of decoys and improving how you pick decoys, like you pick recent ones versus old ones and all kinds of stuff like that. But it just doesn't matter. No matter how well you do at this, 2 purchases, or maybe if you did a really great job at it, then it would take 3 purchases. But it's just fundamentally weak because a small number of decoys out of a large number of candidates is a lot of information, and you can't obscure that information successfully. What were the other things I was going to explain? A what? A million decoys. Right, well, if there's only 1 million total users, and you use all of them as decoys, then yes, there's no information from the successive purchases. So, yeah, then it works. Like if there's 1 million total users and you have plausible deniability, when you deposit that cybercoin, and basically that's what Zcash does. We didn't really get into how the technology of Zcash works, but basically it's the very same. It's roughly the same architecture as Monero, but the zero knowledge proof technology is scalable so that you can prove that your transaction is one of like 1 million. Your source, the sender, is one of 1 million candidate senders, which is like all of them, like of all possible senders that have ever been on the blockchain yet. And that does fix the problem, because then, A, you have the best plausible deniability you can get, which was, hey, you're just accusing me because I'm also a Zcash user, but it could have been any of the other Zcash users, so that's plausible deniability. But more importantly, you don't get this intersection attack, right? If you pick 100,000 out of 1 million, and then you pick a different random 100,000 out of that million, and then you intersect like 10 times, there's only going to be 1 left. Well, I don't know. There's only going to be a few left. But if you have 1 million out of 1 million, you don't get any loss of privacy by repeated use. Yeah. Oh, and that's a possible way forward for Monero, that they could just upgrade, because I've said they've upgraded their technology several times. They could upgrade by replacing the ring SIGs, which allows you to prove 30 or 10 possible decoys, with zero knowledge proofs, which allow you to prove like 1 billion possible decoys. That would fix it. They don't want to use the zero knowledge proofs that we use in Zcash because of the aforementioned parameter generation problem, which poses the risk of counterfeiting. It's a very complicated subject that I could spend another hour talking about. But for reasons which I think are totally valid reasons, the Monero community would never accept upgrading to the current generation of zero knowledge proofs. The current zero knowledge proofs in Zcash are called snarks, S-N-A-R-K. They have this one-time setup problem. But the new ones that aren't efficient enough yet, like Starks, Bulletproofs, and the new thing called Sonic, might be good enough. So maybe Monero could upgrade to that someday. And then they would be as good as Zcash. But was there some other stuff that anybody wanted me to explain? Yeah.
Going back, way back in the discussion when you were talking about actually seeing your transactions on the blockchain, that you're basically decrypting everything. Doesn't that sound very stable?
Yeah, that's one of the problems.
And I would imagine with everyday passing, it becomes that much less
Yep, that's right, yeah. So there's at least two axes of scalability. What to do with the accumulating weight of history, and how to have more and more users without without everything getting slow and expensive. We've been thinking about new technologies to tackle both of those, but it'll be a lot of work.
Is there something that I, as a user, can do? Like, for example, if I know, well, I haven't started using Zcash until, say, January 1st of 2019, so I don't need to look at anything prior to that.
Yep, that would work. It would be nice if your wallet would automatically do that for you.
Yeah.
I mean, in practice it does, because if you run a full node, it syncs the blockchain, right? And then if you generate a new address, it won't rescan the whole blockchain looking for payments to that newly generated address. But if you create a new full node and import that address, then it will need to, then it doesn't know that there aren't already payments to that imported address in the old history. Yeah, so that's one of many areas for improvement for scalability. And the real solutions are basically unsolved problems, like Ethereum and all the decentralized blockchains are struggling with this, right? Bitcoin, and trying to think of different solutions. And we also have the same problem.
What are your thoughts around programmability?
Around what?
Programmability, so stuff.
Oh yeah, smart contracts. Well, we've thought a lot about the technology. Some of our scientists have, by the way, that one called Sonic, the new one, well, Starks also came from some of our founding scientists, but Sonic is the newest one from some of our scientists that I'm excited about, the newest zero knowledge proof technology. Oh yeah, but some of our scientists have published some science papers on how to do programmability using zero knowledge proofs. It's really elegant and awesome, which is like the way programmability works on Ethereum is really inefficient, right? You publish your program, then you publish your inputs, then every miner runs your program on those inputs, and then all the miners agree on what the result is. Okay, with zero knowledge proofs, you can do this instead. You run your program yourself on like one computer, and you generate a zero knowledge proof that the resulting state is the output of running your program. And then you show that zero knowledge proof to all the miners, and then they update their state. So none of them have to run the program. Does that make sense? Well, this has privacy improvements, because now you didn't need to show all the miners your inputs. That's interesting. But it also has major performance improvements, because now the miners don't need to execute the program, they just need to execute a zero knowledge proof verification, and those are actually quite efficient, or they can be, with the right proof system. Anyway, so some of our scientists have written papers about that. The most recent one is called ZEXE, for Zero Knowledge Execution Environment. But I don't think Zcash itself should add that feature, because it would be complicated. It would complicate our scaling problem. Like, I think we can solve scaling maybe with like 3 or 4 years of concerted effort on the part of our whole team. But I don't think we could add arbitrary zero knowledge proof-based smart contracts and also solve scaling. So I think we should solve scaling first. And it would also make things more complicated for the users. I think, I could be wrong, like, you tell me everybody. I'm about to have a poll, so that you have to stop checking your email and start paying attention to me again. So beware. What I think is that a lot of people don't want smart contracts in their money. Like, there's a lot of people who like Bitcoin and don't like Ethereum. Why? Because Ethereum is programmable. No, there's a lot of other people who like Ethereum. Why? Because Ethereum is programmable. Okay, so who would use Zcash more if you could have arbitrary smart contracts in it? Quick count. 1, 2, 3, 4. I'm too tired to count. 11. Okay, and then who would use Zcash less if it had arbitrary smart contracts in it? That guy. 2, 3. All right, I've been proven wrong. What was that, 11-3? I lost count. Anyway, so I don't want to add smart contracts to Zcash anytime soon. I'm pretty interested in adding it after we solve scalability, but that's going to be like 4 years from now. But by then, we'll have a lot better ideas about how to do smart contracts, and we'll have a lot better ideas about what smart contracts are good for.
What if we do it only on the T address?
Well, that's the last thing I want, because I want to deprecate T addresses. I mean, like, retire them. I mean, I'm reconsidering, since there's like 4 times as many people would use Zcash if I change my mind, apparently. 11-3.
Well, I mean, if you could separate the problem of transparency and privacy, so that privacy concerns are addressed with Z addresses,
Yeah.
and transparency aspects, which have
Oh, I have another.
information are addressed with T addresses.
That's a good idea. I have another idea along those lines, which is, let's do a sidechain peg to Ethereum. So now if you want smart contracts, you transfer over to Ethereum, and smart contract your heart out. And then when you want privacy, you transfer back into Zcash.
Yes, yeah. So you pack it on the T addresses and not the Z.
No, I'm trying to get rid of T addresses, so I try not to give them any advantage. So I would peg it to the Z addresses. We can do that pretty easily without too much technology, using the WBTC, wrapped BTC system that already exists.
So that way you will make Zcash a pluggable privacy into Ethereum? Is that the right way?
It'd be like a side chain, or I don't know the right terminology, but there would be there's this thing currently running which is wrapped Bitcoin, which is, it's like a stable coin in Ethereum called WBTC, but it's not pegged to the US dollar, it's pegged to the Bitcoin. And there's these companies or this one company that promises if you bring it a WBTC to redeem, it will give you a Bitcoin. And if you send it a Bitcoin, it will issue you a new WBTC. So it's a stable coin. It's a custodian. I don't know what they call it, custodial, or like it's a stable coin that's backed by an entity, but it's backed by by Bitcoins by that entity. So we could do the exact same thing with Zcash, and then as long as people believe that entity would redeem their WZEX for ZEX, they could go back and forth.
Wouldn't it be kind of a gap in transparency between, because you may not want to show the Z address, but you have to link that to a wrapped version of it, which would be exposed on public Ethereum or some kind of stuff.
Okay, so if you have a Z address, and you have some Zcash in it, you can send some of your Zcash to this custodian entity, and then it will issue you WZEC. Now, as soon as you exit your Z address, you're no longer in the privacy protection of Zcash, right? So when you send the Zcash to the custodian, now the custodian knows something about what you sent, but that's okay. You have to let them know so that they can credit you. But then once they issue you WZEC on Ethereum, now everybody knows that there's this WZEC here. But they never saw your Z address.
And the custodian is the same building.
The custodian, that's a good point. But you don't have to tell the custodian your Z address. You just have to convince them to issue you the wrapped ZEC. Does that make sense?
Doesn't the custodian have to receive the Z?
What's the question?
Doesn't the custodian have to receive the Zcash in Z address?
Yeah, he has to receive Zcash, but you don't have to know the sender's Z address to receive Zcash. But you do have to know who to credit, or like where to send the token.
He needs to know when to send it back if you ever send it back.
Well, the way you send it back, you don't send it back to the original person, you send it to the current holder of the wrapped ZEC token. Does that make sense? Because like you take it to Ethereum and you like bet it on an Augur bet, and you lose, and the winner is the one who takes your token and goes and redeems it for a Zec. So it works that you get both privacy and programmability, but not at the same time. I still think it's cool to use zero knowledge proofs to make general purpose smart contracts and so on, but that's going to be like at least 6 years from now, right? Probably, realistically. It's time to stop. Does anybody have any more questions, though? I like answering questions. All right, you can all stop. Thank you for listening. I don't know. Go check out our website and join our chat room and contribute hacks that the Zcash Foundation wants done.
Thanks for coming. We have